All right, so today we're talking about graphing rational functions. We're not actually going to be graphing yet, but the bigger thing we're going to be looking at is how to use our calculus methods to find limits as x increases or decreases without bound. So what that's telling us is that we want to know what's happening to a limit as x gets larger and larger and larger or smaller and smaller and smaller. Basically, this is saying as x goes to infinity. We haven't done any limits yet where x is going to infinity. In order to evaluate these, there are some things you have to know. It says a limit at infinity specifies a finite value. Finite means not infinity, okay? So if we have a limit as x goes to infinity, it has to be a number, not a value of infinity. Finite means it's not infinite. Approached by a function as x increases or decreases without bound. Here's some things we have to know. We have to know that a constant divided by 0.001 is infinity. A constant divided by negative 0.001 is negative infinity. Here's something we haven't looked at before. If I have a constant divided by infinity, whether it's positive or negative, watch this. If I do any number, say 9, divided by a very large number, look what answer I get. 9e negative 11 means 9 times 10 to the negative 11th. So that means 0.000009. Okay, lots of zeros followed by a 9. So for our purposes, that is 0. No matter what the number is, no matter what the constant is, if I divide by a large number, I'm going to get something very close to 0. This is 4 times 10 to the negative 4. Okay? So, to evaluate the limit of a rational function as x approaches positive or negative infinity, first try substitution. Always. That's what we do first. Plug it in first. If that fails, okay, so one way we've learned about failing is if we get 0 over 0. When we get 0 over 0, we have to do more work. Well, it's also true if we get plus or minus infinity over plus or minus infinity, we have to do more work. But there's a specific thing we have to do, and that is divide each term by the highest power of x in the denominator. This is very important. So anytime we get infinity over infinity, we have to do more work, but this is what we have to do right here. So let's look at example 1. First of all, we try to plug in infinity. When I plug in infinity, I get 5 minus 2 over infinity squared. What did I just say any constant divided by infinity is? 0. So 5 minus 0 is just going to be what? 5. That's the limit here. You also should understand how this would look from a graphing perspective. If I'm putting this in, 5 minus 2 divided by x squared. Here's the way the function looks. If you get stuck on a quiz and you need to find the limit as x goes to infinity, just hit trace and trace it. We want to know as x gets larger and larger and larger, what is y getting closer and closer to? If I sit here and hold this for the next, 30 minutes until class is over, what's it just keep getting closer and closer to? 5. Guys, there's no reason to ever miss a limit problem. I let you use your graphing calculator. I expect you to support your answer analytically, but you can use your graphing calculator to check things. It's kind of mesmerizing, isn't it? Just to sit there and watch it. It's going 4.9999. Just keeps getting closer and closer to 5. Okay? That's what we mean. The limit as x gets larger and larger, what's the y value approaching? A real world application of this would be as time goes on, there's usually kind of like a profit level that a company would level out to. And that's what this kind of limit can be related to. If this was our profit function, as time goes on, maybe this is in millions. Maybe our profits are approaching 5 million as time goes on. Okay? All right, for this one, I try plugging in negative infinity. 2 times negative infinity is still negative infinity. Minus 1 is still negative infinity. There's nothing you can do to infinity to change it, okay? If I multiply it by 2, add 1, divide by 1,000,000, I can't change it. Infinity cannot be changed. Plug infinity into the bottom. Negative infinity plus 1 doesn't change it. It's still negative infinity. So when I get negative infinity over infinity, negative infinity, I have to do more work. But the specific work I have to do is to divide each term by the highest power of x in the denominator. Here's the denominator. My highest power of x is x to the first. So here's what I'm doing. I'm taking this limit. I have to divide 2x by x. I have to divide 1 by x. I have to divide x by x, and I have to divide 1 by x. Now I'm going to simplify that. 2x divided by x is 2, minus 1 over x. X over x is 1, plus 1 over x. Now I'm going to plug in my negative infinity. So I'm going to have 2 minus 1 over negative infinity. 1 plus 1 over negative infinity. What did we say up above any constant divided by infinity is? 0. So if I have 2 minus 0 over 1 plus 0, what's the answer to this? 2. So the limit equals 2. Okay? On example 3, I'm going to plug in infinity. Negative 2 times infinity is infinity, plus 3 is still negative infinity. 3 times infinity squared is infinity, plus 1 is still infinity. Do more work. But I don't have to do any factoring. What I have to do is divide by the highest power of x in the denominator. So what am I going to divide each term by? X squared. So I'm going to have the limit as x approaches infinity, negative 2x over x squared plus 3 over x squared, 3x squared over x squared plus 1 over x squared. Simplify. This is going to be negative 2 over x plus 3 over x squared. 3x squared over x squared is 3, 1 over x squared. Now we're going to plug in our infinity. So it's going to be negative 2 over infinity plus 3 over infinity squared, 3 plus 1 over infinity squared. Well, what is the constant over infinity again? So I'm going to have 0 plus 0 divided by 3. So what's this limit going to be? 0. Suppose we feel like we did something incorrectly there. Well, if I wanted to double check it, I can just put in the fraction. It's going to be negative 2x plus 3 divided by 3x squared plus 1. I can now do a zoom 6. Here's the way it looks. I want to trace it as x goes down to infinity. So if I push my second calculate to trace, oops, second. I didn't want to do second, just trace. And as I move this down here, as x goes down to infinity, I can see that my y value is getting closer and closer to 0. Okay? All right, let's get a little bit quicker with this now. I'm going to plug in negative infinity. Negative infinity squared is infinity, and times negative 2, I can't change it. It's still going to be infinity. Negative infinity squared is infinity, times 3 plus 1, still infinity. Now, let's try not to show this division. What am I going to divide everything through by, Blake? Because I'm squaring it. So what if we got infinity over infinity? What are we going to divide through by then? X squared. So instead of writing that, let's just do it. Negative 2x squared divided by x squared is what? Negative 2. Plus 3 over x squared over 3x squared divided by x squared is just 3 and 1 over x squared. Any questions on how I got that? So now I'm going to plug in my negative infinity. So I'm going to have negative 2 plus 3 over negative infinity squared, 3 plus 1 over infinity squared. Well, what are these things here going to be? 0. So what's the answer for the limit? Negative 2/3. And I could put that into my calculator and I could see what happens and I could double check it. All right, what about here? What are we going to divide through by? X squared. So my result is going to be, I should have checked this first. Yep, I'm going to infinity. I get infinity over infinity. So if I divide this by x squared, I'm going to get what? 2x. When I divide 3x squared by x squared, that's just 3. And then 1 divided by x squared. So now, instead of showing I need to plug in infinity, I can change my x's to infinity, right? That'll save me a little writing too. Okay, so what are each of these two things? 3 over infinity squared is just going to be 0, and 1 over infinity squared is 0. So what's 2 times infinity over 3 going to be? Infinity. Okay, so this limit is going to be infinity, which actually then we could say, you can either answer it as infinity, or you could even say the limit does not exist. I would accept both of those answers. Here's why. The definition of this says that the limit of a rational function as x approaches first try substitution, but up here, this is the part I was talking about. A limit at infinity specifies a finite value. Is this answer finite? No, it's infinite. But it would help us to understand the behavior of the graph, and that's why I would allow you to put infinity. Okay, but what that means is that this function actually just goes on and on and on. Let me just show you what this looks like. This is going to be 2x to the third plus 3. Oh, goodness. Hold on. I always forget to get out of the exponent. Okay, so if I look at this, here's the way it looks. Can you see it even? See as x gets higher and higher, y is getting higher and higher? Double check it. All right. So the last one, what are we going to do on this problem? What's that? Plug in what? Plug in 3. So I plug in 3. 3 plus 3 is 6. 3 times 3 is 9. Plus 1 is 10. Do I now divide everything through by x? No. What's the answer? 3/5. Don't get to that point where you learn something new in calculus and you're going to use it on every single problem. Okay? We only divide through by the highest power of x if we get an answer of infinity over infinity. If I get an answer, that's my answer. I stop right there. I'm not going to do anything else with it. It does not require more work. Okay? All right. This one, it says you can also complete a table to estimate the limit as x goes to infinity. And I've shown you that, like how we can just substitute in. The reason why this one's a little trickier is because it's actually x plus 4 over, does anyone know what this exponent would be if it's x radical x? 3 over 2, somebody said it. It's x to the 3 over 2. Because it's actually x to the first times x to the 1/2. So what you could really do is divide each power by x to the 3/2. You could do it that way. But I wanted to show you how, if you didn't understand that way, you can still do the problem. You can just do x plus 4 divided by x to the 3/2. And then you can graph it. Now, we want to check these values because we want to know what's happening as x gets larger and larger. I've shown you how you can use a trace, and trace is pretty good, but you don't know for sure if you're really getting out there far enough, because what happens is that sometimes these graphs can turn around. This graph could start shoot up down here. So what this is saying is check 10 to the fourth, which is what, 10,000, and check 10 to the fifth. 10 to the fifth would be 100,000. So it's telling you to check these really super large numbers. So if I do second trace calculate a value, if I want to check 10 to the fourth, it says I can't do it. It says I'm attempting to use a variable or function where it is not valid. Well, that means I have to change my window. I've got to graph this out to 10 to the sixth. And I might even want to go a little bit further, like 10 to the sixth plus 3. I'm going to see if it'll do that. I don't know. We'll see. I'm just saying I have to go out a little bit further than 10 to the sixth to be able to check it. So here's the way it looks. I can pretty much see what it is, but just to complete the chart, second trace, calculate a value. When x is 10 to the fourth, I get 0.01. When I check 10 to the fifth, I get 0.003. When I check 10 to the sixth, I get 0.001. So what do you think this limit must be then? 0. The limit is 0. Okay? Any questions? All right, I want you guys to try these 3 review problems. Let's change this to a 3, though. On number 2, make that a 3. I want you to find the limit on this one, any vertical asymptotes and holes, and then find the limit as x approaches the vertical asymptotes from the left and right. See how you do. Okay, guys, I saw some good things out there. Getting a little short on time, so I want to go ahead and see what you got here. Stephanie, what did you get for number 1? 3/8. Very good. I saw some people with answers of infinity and negative infinity. No. See, we're just approaching +4, so you just plug in 4. So 3/8. If it had said -4, then you would have had answers of infinity or negative infinity, because it would have been a vertical asymptote. All right, what about number 2? Who has number 2? Faith, what do you have?
Hole at x equals 3 and the vertical asymptote at x equals 4.
Good. So on this one, you should have factored the denominator. These two cancel. So we are going to have a whole at 3. Now, guys, I want you to be able to find out exactly where that whole exists. So when you get that 3, you should plug it into what's left over. So if we plug 3 into what's left over, 3 minus 4 is negative 1. 1 divided by negative 1 is negative 1. So right there is where the whole is. So I want you to write the whole as an ordered pair. And then she said there'd be a vertical asymptote at x equals 4. And that's because there was no canceling out with the numerator there. And then the last one, it says to find the limits as x approaches the vertical asymptotes. Well, if we factor this, those canceled, so that was the whole. So we've now had to find the limit as x approaches 4 from the left, and the limit as x approaches 4 from the right. That's where our vertical asymptote is. So I'm going to have to check from the left first. Emily, what's a number a little less than 4? Right. So I have a 1 on the top. I'm going to plug 3.999 in on the bottom. And so what are we going to get for that then? Tyler, what am I going to get? Okay, so I'm going to get 1 over negative 0.01. And so what does that mean that limit's going to be? Good job. And then on this one, I have to plug in something a little bit bigger than 4, like 4.01. That gives me 1 over positive 0.1, and so that's going to be infinity. Okay? We also could look at it and see that. Just let me show you real quick how you could have looked at it. Let's say you're taking a quiz and you're just getting confused and not sure what to do. Just type it into the calculator. Do a zoom 6. We want to know as x approaches 4 from the negative side. Can you see as x approaches 4 from the negative side, we're approaching negative infinity and positive infinity. It should all work together. Okay, guys, very good. I have a worksheet for you.